Step-by-step exam solutions. Okay, maths class, training you to excel. Subscribe. Give a thumbs up. Share with friends. Click the notification button so that you receive the next publication. Step-by-step exam solutions. Okay, maths class, step to exam success. Step 1, plan. Step 2, pray. Step 3, prepare. Step 4, preview. Step 5, perform. Okay, maths class, step-by-step exam solution to graphs of quadratic functions. In this presentation, we'll be looking at graph of functions. Number 1, linear function, quadratic functions, trigonometric functions, and inequalities. But in this particular presentation, we're looking at graphs of quadratic functions, and our objectives are: 1. Obtain or complete a given table of values. Choose a reasonable uniform scale. Correctly plot the coordinate point. Answer questions based on the graphs correctly. In this presentation, we are looking at WAEC May-June 2021. Copy and complete the table of values for the relation y is equal to 2x squared minus x minus 2 for x starting from minus 4 to plus 4. Using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on the y-axis, draw the graph of y is equal to 2x squared minus x minus 2. C. On the same axis, draw the graph of y is equal to 2x plus 3. D. Using the graph to find the 1, the root of the equation 2x squared minus 3x minus 5 is equal to 0. 2. The range of values of s for which 2x squared minus x minus 2 is less than 0. Let's see how to solve these questions together now. So we're going to complete a table of value for the function 2x squared minus x minus 2. So when x is equal to minus 4, we're going to replace x here with minus 4. We replace this also with minus 4. Then we're going to simplify. Minus 4 squared is 16. And then minus times minus 4 is plus 4. Then we'll bring down minus 2. 2 times 16 is 32. Then plus 4 is 36. Then minus 2. Y will give us finally 34. So the value of y when s is minus 4 is 34. We're going to repeat the same process for x equal to minus 2. So we replace x here with minus 2. Replace x here with minus 2. On further simplification, minus 2 squared is 4. Then minus times minus 2 is plus 2. Then we'll bring down minus 2. So we're going to have 8 plus 0 because plus 2 minus 2 is 0. So therefore y is equal to 8. Now for x equal to 1, so we're going to replace this with 1, replace this with 1, and on simplification we are going to have 2 times 1 plus 1 minus 2. 2 plus 1 is 3 minus 2. The final answer will give us 1. So x is equal to 1. Y is equal to 1 when x is equal to minus 1. Then we're now going to repeat the same process from when x is equal to 1. Then we replace this with 1, and then replace this with 1. Then on further simplification, this will give us 1, this will give us minus 1, and minus 3. This will give us 2 minus 3. Then finally, we are going to have minus 1. So when s is equal to 1, y is minus 1. Then we are going to do the same thing from when s is equal to 2. Replace this with 2, replace this with 2, and then simplify. 2 squared is 4. Minus times 2 is minus 2. Then bring down minus 2. Simplifying this will give me 8. Minus 2 is minus 4. 8 minus 4 will give me y is equal to 4. And then finally, when x is equal to 3, we are going to replace this with 3, replace this with 3. And then we're going to simplify. 3 squared is 9, and then minus times 3 is minus 3. Then bring down minus 2. Then we're going to simplify. This is 18, then minus 5. So y is equal to 13. We have completed the table of value for the quadratic function. y is equal to 2x squared minus x minus 2. We're going to move to the next slide to get the table for the linear function. Now the linear function is y is equal to 2x plus 3. So y is equal to 2x plus 3. So we're now going to replace x with minus 2. So if we do that here, we're going to have minus 2. And then simplifying, this gives minus 4 plus 3. This gives me 1. We'll do the same thing for when x is 0. So we're going to replace x with 0. 2 times 0 is 0 plus 3. Then y is 3. Then we're going to do the same thing for when x is equal to 3. Then replace this with 2. And then 2 times 2 is 4 plus 3. The answer will give us 7. Now we have also completed the table for the linear function. Then we're going to move straight to the graph page to plot the graph. Now we're going to drop our axis. This red vertical line is y-axis, and the horizontal line is the x-axis. Remember, on the y-axis, the scale is 2 centimeters is equal to 5 units. So every 2 centimeters will give us 5 units. So this is 5, this is 10, this is 15, 20, 10 to 35. Now, between 0 and 5, we have 10 small squares. 10 divided by 5 is 2, meaning that 2 small squares is equal to 1 unit on the vertical axis. Now, looking at the x-axis, 2 centimeters is equal to 1. And we have 10 small squares. 1 divided by 10, meaning that 1 small square is 0.1. Now, with this scale having this scale in mind, we are going to now plot the graphs. When x is equal to minus 4, y is 34. Minus 4 at this point, then 35 is here. We drop 2 small squares, giving us 34. Remember, 2 small squares is 1. So 35 minus 1 is 34. Now, when x is equal to minus 3, y is 19. This is minus 3. Then this is 20. Drop 2 small squares below 20. That's 19. When x is 2, y is minus 2, y is 8. Then 8, if this is 5, this is 6, this is 7, and then this is 8. Then when x is equal to minus 1, y is 1, minus 1. 2 small squares above the 0 axis is 1. Then when x is 0, y is minus 2. X is 0 along the y-axis. This is minus 1, and this is minus 2 at that point. When x is equal to 1, y is minus 1. 1 here. 2 small squares down give us minus 1. When x is equal to 2, y is equal to 4. Now, that 4 means from 5, I count 2 small squares down to give me 4. 13. Trace, y is 13. Then we have, this is 10, 11. Another 2 small square, 12. Another 2 small square, 13 at that point. Then when x is 4, y is 26. Now, from 25, we count 2 small square up to add to 25 to give us 26. Now, we are going to join these points with a smooth curve, starting from this end. The blue line represents the quadratic function. Y is equal to 2x minus s minus 2. Now, with this table, we are going to plot the linear function using the same scales. When x is equal to minus 2, y is 1. X is minus 2 here. Y is minus 1. That's at this point. When x is equal to 0, y is 3. X is 0 along the y-axis. And y is 3. 3 should be at this point. When x is equal to 2, y is 7. So this is 5. 2 small squares is 6. The next 2 small squares is 7. So that's the point. We are going to join these 3 points with a straight line starting from this end. The red line represents the line y is equal to 3x plus 3. Now we are going to answer our questions. The first question, we are asked to use the graph to find 1, the roots of the equation 2x squared minus 3x minus 5 is equal to 0. This equation is different from the original equation. So therefore, it means that this equation must be related to the original equation 2x squared minus s minus 2 and the equation of the straight line y is equal to 3s plus 3. So therefore, the roots of the 2x squared minus 3s minus 5 is equal to 0 are the point of intersection of the function y is equal to 2x squared minus x minus 2 and the function y is equal to 2x plus 3. So now that means 2x squared minus s minus 2 will be equal to 2x plus 3 at the point of intersection here and here. So now taking 2x plus 3 the other side, then we have this is equal to 0. On simplification, we have that 2x squared minus s minus 2s minus 3x minus 2 minus 3 is minus 5, which is the equation we're asked to solve. So therefore, the solution of this equation is the point of intersection of the curve and the straight line. 1 is at this point. So we're going to find the value of x at this point. We drop a vertical line to the x-axis. That gives us x is equal to minus 1. The same thing at this end also. We drop a vertical line from here. X is equal to 2.5. So therefore, the solution of D1 will give us the roots of 2x squared minus 3s minus 5 will be s is equal to minus 1 and s is equal to 2.5. Then we're going to go to the next question. The range of values of s for which 2x squared minus x minus 2 will be less than 0. And we have the x-axis dividing the quadratic function into two parts. One above 0. That's this end. Y is greater than 0. But we are looking for the portion where y is less than 0. Remember, 2x squared minus x minus 2 is y. So therefore, y is greater than 0 is rejected. So therefore, the correct portion is where y is less than 0, below the x-axis. So that's the part that will satisfy that inequality. So therefore, the values of x for which y is less than 0 is where the blue quadratic curve crosses the x-axis at this point and then extend to this point. So now we're going to find that value. Looking at this is 0 here, this is 0.5, 0.6, 0.7, this is 0.75 minus 0.75, and this is 1, 1.1, 1.2, and 1.25. So therefore, the answer will give us minus 0.75 and 1.25. So the range is from minus 0.75 to 1.25. Therefore, minus 0.75 is less than x, and x is less than 1.25. That brings us to the end of the presentation. Thanks for watching. Remember to subscribe.